If you're leading programs in aerospace or defense, and you're looking to move beyond prototyping, this is for you. Welcome to End-Use Part Production in Aerospace and Defense, Episode 1 of our webinar QuickTake series. We've pulled the key moments from a roundtable with Sikorsky, General Atomics, Materialise, and Stratasys, focused entirely on production-ready additive manufacturing. We'll cover qualified flight parts, digital infrastructure, simulation economics. But stay with us till the end to hear the one shift that turns additive from a tactical tool into long-term strategic advantage. And if what you hear sparks deeper questions, the full session is available on our website, with the workflows, data, and detailed answers behind what you'll hear today. Let's get started. Section 1. Additive is for end-use production. A few years ago, additive manufacturing in aerospace was all about prototyping. Early adopters were proving the technology, testing processes, qualifying materials, ironing out the kinks. That phase is over. Today, additive is in full swing, with certified end-use part production scaled across leading programs. At Sikorsky, that shift is already well established.
So to start off, here at Sikorsky, I've been here, like I said, almost 6 years, but I was here when we had one printer, and now fast forward 5 years later, and we have over 20 just over at Sikorsky.
And it's not just machine count, it's flight qualified output.
So we have several hundreds of part numbers that are qualified for flight now.
This isn't a test phase, this is production. Additive is delivering certified, repeatable parts across operational aircraft programs today. And as you'll see next, what counts as a production part goes well beyond what flies. Section 2. What counts as a production part? So what exactly counts as a production part in additive manufacturing? It's not about quantity, it's about qualification. What matters is whether the part can be repeated, tracked, and trusted across shifts, teams, and facilities. At General Atomics, Steve Fournier explains how their team draws the line, based on function, not just flight status.
Production really is anything that has fully functional requirements, and it has an end use that is in our product line. So for us, it's in flight. It could also be ground systems, but really has a set of requirements. And that, I would say, extends to tooling. We do a lot of tooling using additive manufacturing, and some of the toolings are fixtures and things that go on the workstation. That's not necessarily what I call production tooling. Production tooling are what affects the rate production tool parts that you use those tools for. So there's a much more stringent set of requirements related to those type of parts. And that triggers that data stream, that data rich environment in the production environment. So for us, for example, we have several thousands of parts produced in production level produced every year.
This distinction between general tooling and rate tooling is a key point. Once a tool impacts throughput, it becomes part of the production system and gets treated accordingly. At Sikorsky, Josh de la Hoz puts it plainly. It's all about the process behind the part.
Production part for us is anything that has a controlled process behind it. Whether that be a tool, whether that be a component that's aiding in aircraft, or at the end of the day, a part that's flying on aircraft.
And that mindset opens the door to real flexibility on the floor.
We don't only have to use a printer for simple shop aid tools or trinkets or smaller pieces. We can really use these for end-use production parts that either fly on aircraft or are helping aid in the assembly of our aircraft here at Sikorsky.
From ground support to airborne systems, additive is now touching every layer of aerospace operations. It's not just producing more flight-ready parts, it's enabling the tools that make those parts possible. Clamps, jigs, fixtures, robotic grippers at the end of automated arms. The components that shape production, guide assembly, and keep rate on track. This is the infrastructure of modern manufacturing. And it's giving teams the speed and flexibility they need, exactly where they need it. So let me ask a quick question before we dive into Section 3. What's your biggest hurdle when it comes to adopting or scaling additive? Comment below. We'd love to hear where you're hitting friction. Section 3. Digital infrastructure. Everyone talks about machines in additive, but without the right infrastructure behind them, they won't scale. At General Atomics, Steve Fournier makes the case plainly: your software stack matters just as much as your hardware.
When you start additive, you need to recognize a certain threshold where Excel spreadsheets no longer do it.
Because once additive starts to scale, Excel isn't going to cut it. Not for part traceability, not for validation workflows, and definitely not for managing a production fleet. And once you pass that threshold, connecting the data is critical.
That is really important, to have a matching data stream and being able to connect the digital thread at that level as well.
From a production standpoint, that means ideally connecting all the right dots and building the right infrastructure from the ground up.
We need to set up the infrastructure ground up.
And that knowledge needs to move with the part across every stage of validation and delivery.
And it's about, and as Steve did mention, about identification and distribution of technical data packages, and about recipe management. And all of that is so critical for production and part validation at each step, like not just for printing, not just for printer control, but post-processing, measurements, and all of that.
That's why platform openness isn't just a nice to have. It's a strategic lever for integration, flexibility, and future-proofing your operation. As aerospace and defense programs expand their AM use, open platforms ensure your printers, software, and workflows can scale without locking you into a single ecosystem.
Part of our strategy to enable the advancement of production AM parts is to have an open platform so that our software and our printers can be integrated into the software backbone that companies like Lockheed and General Atomics are trying to build.
And as Ryan Martin at ABI Research puts it, AM success doesn't happen in isolation.
To end-use part production is really not just about the machines, it's also about the software and the ecosystem that enables production. Because as we know, production just doesn't happen in isolation. It's really about all the different components used to get a part from design to its actually used in the field.
Traceability, version control, integration across teams and technologies. This isn't back-end architecture, it's the foundation of production reliability. Section 4. Predictive maintenance. Additive fleets are already deployed, and as they grow, so does the operational burden. Production isn't forgiving. One machine offline can disrupt delivery, derail programs, and drain momentum. Uptime isn't just a metric, it's a risk factor. At Sikorsky, they've seen that shift firsthand.
Because we've scaled up substantially, because we have an increased number of machines, we need to have that information. We need to have the information readily available, readily viewable, which I think is key, and understandable.
That visibility isn't just about dashboards. It's about catching issues before they disrupt output.
It's giving me the ability to view live data. It's giving me the ability to save job information in such a way that I can now correlate that specific data to real life events. I've seen examples of that here internally where something were to fail and we catch it too last minute. We need to eliminate that, right? And that's where that preventative maintenance comes in.
When delays ripple through build schedules or interrupt readiness for critical missions, even minor downtime can have major consequences. Proactive monitoring isn't just smart, it's now essential. Because in aerospace and defense, predictive maintenance helps keep parts moving, programs on track, and teams focused on delivery. Have you ever had a print fail because something slipped through the cracks? Tell us your biggest AM maintenance headache. We'll feature solutions in future episodes. Section 5. Simulation and the economics of additive. Once additive production is established, two questions rise to the top. How do you maximize efficiency? And how do you justify every build, technically and financially? Simulation helps answer both. It's not just about predicting distortion or support needs. It's about avoiding failed jobs, trimming costs, and building a solid business case for AM at scale.
Huge aspects of our focus is build simulation. I mean, failing electrons is much cheaper than failing powder and lasers and machine time.
Simulation isn't just about distortion modeling or thermal gradients. It's about controlling cost, before you hit print?
Yeah, I mean, I'll touch on something again that one of the panelists said earlier was around the economics. Once you've proven that AM can produce end-use production parts, then the next question is how do you squeeze every drop of value out of it? So I think one area for simulation isn't just structural, but it's actually the cost estimation and the cost calculations, so that companies like this can make optimal choices. I think both panelists talked about making the business case for AM, and why wouldn't the software be contributing to helping to calculate the cost, and even to help to identify the optimal economic scenarios for building.
As AM moves into more departments, supply chain, logistics, MRO, the cost of system misalignment rises fast.
Because we know, and some apps need to identify new parts to be produced. Some apps need to do logistical and downstream management. Some apps need to improve the ERP and the CRM components. And ultimately, all of that is the connected digital thread. And there's a lot of non-recurring costs, the hidden cost, if that is all disconnected because of errors and manual errors and whatnot.
So what's changed? According to General Atomics, the pull is now coming from inside, from teams who see the value and want to scale it.
The trend has kind of flipped over from pushing additive over several years ago into a pull. So we get a fast growth and a pull from multiple different vectors within the company on how we can use additive, because I think we've reached a critical mass of knowledge and additive ecosystem in place.
From internal demand to simulation-led decisions, this is how additive matures. It's not a pitch anymore, it's proof. Additive's business case is now built on real metrics. Machine hours saved, build plans optimized, and qualified parts that bypass traditional supply chains entirely. This isn't just efficiency, it's a shift in how manufacturing teams plan, produce, and perform. We're about to reveal the shift that changes how additive fits in strategy. But first, what role do you see AM playing in your long-term plans? Drop your take in the comments below. Section 6. Building strategic resilience. This is the moment we've been building toward. The shift that turns additive from a tactical tool into a long-term strategic advantage. Global trade friction, tariffs, and unstable supply chains have exposed serious vulnerabilities in traditional aerospace and defense logistics. And additive manufacturing, especially distributed AM using FDM, is how many are responding. Instead of relying on stockpiles or international freight, qualified parts can now be printed locally from encrypted digital files. The impact? Faster lead times, lower risk exposure, and more flexibility when it matters most. Here's what it unlocks: on-site production of spares and certified parts, faster R&D and shorter time to field, less reliance on long-haul logistics, and built-in adaptability with compliance in mind. So who benefits? Government programs with regional operations, OEMs looking to de-risk production, and suppliers who want speed and credibility without massive upfront cost. Bottom line? Additive isn't a stopgap. It's a forward-leaning strategy, and the companies getting ahead are treating it that way. To activate it, start screening your parts for additive. Use 3D scanning to create digital twins faster. Build a roadmap that aligns with your compliance and performance goals. And work with partners who've already walked this path at scale. Even if global pressures ease, the need to stay agile won't. Additive gives you the control, the speed, and the confidence to respond on your terms. And with that, we wrap up end-use part production in aerospace and defense, episode 1 of our webinar QuickTake series. We're incredibly grateful to the panelists for sharing their insight, experience, and forward-thinking strategies. If this QuickTake gave you something useful, insight, strategy, or even just a fresh perspective, tap that like and subscribe button. It's how we know this is the kind of content you want more of. And don't forget to turn on notifications so next time you're on YouTube, you'll see when we post something new. This is just one part of a growing library. Alongside webinar quick takes like this, we'll be sharing insights from white papers, case studies, product showcases, events, and more across every industry we serve. So follow us on socials to stay ahead of what matters. All the links are in the description below. Thanks again for watching, and we'll see you in the next one. If you like and subscribe, that is. Bye for now.